Right, we shall start today talking about uh, the recampering, right? So first, open the Civil 3D drawing like this. Now, recampering is of course really important for the rehabilitation road projects, right? Not for national roads, not national roads, not for new roads. Okay. So we'll open the previous day's drawing. So that is here, alignment 2. Here now, so far what we have done is we have created the alignment, and last day after that we created offset alignments as well. Okay, after that we created the existing profile here, and then we inserted the super elevation. Okay, that is all we did last day. Now today what we are going to do is we are going to create the recampering profile. So what do we mean by recampering? Now please pay your attention. Recampering, if you are going to search this in the Google or whatever, I don't think there is any chance that you can find this. Okay, why? Because maybe the recampering is something that we term in Sri Lanka. Okay, but the process is there, but only thing is I don't know whether the other people are calling it recampering, or you can say camber adjustments or something like that. Okay, for our convenience we call it recampering. Okay, so please understand the process is there, but sometimes they may be terming it differently. Okay, so what I say about recampering is, now you know usually an existing road is like this. Okay, this is the cross section of an existing road. Just think. After that, now I'm changing the layers. Don't think about it. Just because to change the color I'm doing. Okay, there's nothing about the layers. Okay, so what I'm going to say is, now if this is your existing road, now if we are going to have our design road like this is perfectly okay. Now just think that your pavement thickness, we will say 100 millimeters, 40 wearing cost, 60 binder cost, we'll say like that, right? Now if you are going to give 100 millimeter thickness on top of the existing road, now what happens is in the center line there will be a thickness of 100, so that will be shown here somewhere. Why? We are showing only the levels in the center line only. Understand, we are showing the levels in the center line only. Therefore, if your design center line is coming like this, it will show there is a 100 millimeter thickness there. Understood? Then this is not a problem. But just think that your alignment is such that your new crown is not coming on top of that. Your new crown can be changed like this. We'll say now your new crown is like this, right? Now if you are going to check the center line levels, so that is what they are showing here in the profile view, the center line levels. Now if you are going to see the levels, maybe you will see here it is more than 100 millimeters, so maybe 150. So you will think, okay, I'll reduce these levels a bit, so you will take it down lower to do like this. Okay, now 100 millimeters is there, but the problem is one side you are going to what, to cut the road. Is it necessary? It's not necessary. What you could do is you could set this level such a way that minimum 100 millimeter thickness is ensured. So here the minimum thickness is coming in this point. This is 100. So then this may be 250. Can't help. Okay. Understood. So this is what we call the recambering. So that means we change the levels. Now earlier it was somewhere here. Now we raised it. Okay, we raised it. The center line level we raised is to match with the existing cross section. That is what we call the recambering. Okay, so what we do is we are going to create a surface. We are going to create a surface ensuring that minimum thickness is there throughout the rod, not only in the center line. Now do you understand? Any questions about recambering? So I call it recambering. Please understand. In some other places, it may be called as camber adjustment. Now, if you are going to go to Middle East or somewhere, don't go and say, I want to do recambering. They will not understand. Just say the camber adjustment. So I want to do the camber adjustment. So that is plain English. If you say camber adjustment, that is plain English. Now, in of course, in Middle East, I don't think you will have to do the camber adjustment or anything because they are going to go for new roads. This is for rehabilitation road projects. Okay, so wherever you go, use the word camber adjustment, so that will be possible for others to understand it. But we call it here in Sri Lanka, we call it recambering. Okay, so now today I'm going to teach you one method to do this in Civil 3D. Now of course you are going to do this manually. What you have to do is, now earlier before the Civil 3D came, how did they do? So you had to draw cross section everywhere. Okay, from 10 meter to 10 meter you had to draw the cross sections, the existing cross sections like this, and then you have to check what is your the where your center line falls, the new design center line falls, and you had to ensure that minimum thickness everywhere, and then you had to find out this level. That is how you are doing it manually. Okay, you draw the existing cross section and then you have to draw the new cross section in such a way that everywhere 100 millimeter is satisfied. But now it is not a big thing. We can do it using Civil 3D. How we are going to do it using Civil 3D? Of course, what we do is we are going to create something called a corridor. Okay, corridor in the sense we are going to run a typical cross section throughout this rod, giving some conditions. So you have to run this cross section throughout the rod under, I mean subject to some conditions. What are these conditions? These conditions are, you have to make sure that minimum thickness 100 millimeter is uh, kept throughout the rod, not in the center line. Everywhere if you go and check, 100 millimeter minimum is there. So that is the condition. Depending on that condition, you have to run that typical cross section. So uh, actually in Civil 3D, such a typical cross section is called an assembly. What do you mean by an assembly? So you go and assemble something together. Okay. Now, of course, in software, if you are going to write a software something, sometimes you might have heard that people take some software component, okay, the programming component, and then put them together. Okay, and then you make a new program. So like that, in assembly also, what you do is you have an assembly center line, then you take some components, they are called sub assemblies, and then you make an assembly to match with the typical cross section of this rod. Okay, so shall we start? Now, if I want to, yeah, if you want to follow, if you want to follow this book, I'll just say the here 48, page number 48. Creating the recambering profile. So there is a small introduction that I have given. Usually the roads are cambered towards the center line. When a new design is done for an existing road, the new center line does not necessarily follow the exact previous center line. Okay. This raises the need to change the camber towards the new center line. In doing so, sometimes the road cutting may be required, which is usually not allowed in the rehabilitation projects. So the recambering is carried out to make sure the minimum thickness required by the pavement design is ensured throughout the road, and no road cutting will take place in the construction. So now we are going to do this, creating the recambering assembly. Okay. So for that, so I will delete these things. So you come to these corridors, create assembly. Corridors, create assembly. Do it with me, right? Corridors, create assembly. So they ask the create assembly dialog box comes. Yeah. So the name is usually I give RC. That's for recambering. Okay. Then the assembly type should be undivided crown road. Why? The road is undivided. There is no center median, and it's crown. It's not planar. Okay. And assembly style is RD assembly. Code set style is RDA finish. Okay. So how we are going to do it? Corridors, create assembly, and give the name as RC. If you want, you can give whatever the name you want. And assembly type should be undivided crown road. Assembly style is RDA assembly. Code set style is RDA finish. Okay. Then press OK. So it says specify assembly baseline location. Usually I give the location somewhere near this profile view, because once created it is very small. See, very small. It's very difficult to find. So what you can do is you can draw a circle around if you want. Otherwise it's difficult to find out where your assembly is. Now this is your assembly. Assembly is essentially the center line of the design design center line, the cross section. Okay, right. Then we have to give the components. So the component is the component of this road is, there is this. Now we are thinking about this existing road. Okay, so we are going to run the existing road, because uh, you have to make sure that 100 millimeter is kept throughout the road only on the existing center line. Sorry, existing road. Beyond that, there is no such requirement. Okay, understand? You have to have the minimum 100 millimeter thickness pavement design only within the bounds of the existing road. Why beyond that there is no existing road? So why why do you want to have 100 millimeter there? The minimum one. So you can do whatever you want. 100 millimeter should be there, but it should not be on top of that soil. Understand what I'm telling? Or you don't understand? Now what I am telling is, now our new road is usually wider than the existing road. Usually. Okay. So usually it is wider than our existing road. Now what happens is, if your pavement design given as the minimum pavement thickness 100 millimeter should be maintained throughout the existing road. Now, beyond the existing road, the widening section, what can be the pavement design? So it can be 100 millimeter uh, asphalt, then maybe 200 millimeter ABC, 300 millimeter soil. This can be, right. So is there any recambering requirement uh, beyond the existing road towards the towards the widening section? No, the recambering requirement is coming only within the bounds of the existing road. Understand? Right. So we are going to model the existing road here. Now we have the center line. We are going to model the existing center line. So please take this general tool palettes window. General tool palettes window. And here in this set of tabs, find if there is something called rehab. It's there, rehab. If it is not there, you come to this flip-in section. Can you see this flip-in section here? And right click, and there will be rehab. Here, rehab. Okay. So how you are going to take it? General tool palettes window. Now find out if there is rehab there in this tab, in the set of tabs. If you cannot find it, in this flip-in section, you right click and find rehab. Here rehab is there. Okay, and from the rehab you have to find this overlay mill and level 2 subassembly. Found it? Okay, overlay mill and level 2, right? Any questions? Today's Zoom class is very silent. Why? Right, overlay mill and level 2. You select it. Once you select, it says create subassembly tool. Select marker point within assembly or insert. Now there comes a question. What is mill and level 1? So that is a different one. Okay, so we are not going to use it here. Later I'll tell where you are going to use it, right? So please concentrate on this overlay mill and level 2. That is the one that we are going to use on top of an existing road for such a road. Okay, so you select it, then it says select marker point within assembly. So you can select this blue color circle. Please understand, you are going to select it once. Okay, don't select it twice. Then there will be two sub assemblies coming, right? You select it, be very careful, right? Select it and then press escape. Okay, select it once and press escape. Okay, now this is your existing road. Do you see it as an existing road? Huh? They are just some few circles. Okay, but anyway, once we give the parameters, it will become a road, right? So you select this the sub assembly and right click, go to sub assembly properties, and you go to sub assembly properties, right? So then the sub assembly properties overlay mill and level 2 dialog box will come. So you go to parameters. Okay, now you have to give the relevant parameters. Now if you have any question about these things, what are these crown point offset, left sample point offset, right sample point offset, like this, here there's something called sub assembly help. You can click it, so it will go to the Autodesk website, and it will show what are these things here. This is left overlay slope, right overlay slope, this is the overlay depth, and this is the minimum clearance. Can you see? This is the minimum clearance. Okay, and right existing, so this is the crown point, left existing stop, left trim point, right trim point. Okay, so it is there. Also it is described here. If you have any questions, you can find it from here. Okay, now we will give the parameters. Shall we start giving the parameters? Crown point offset in the sense, if you're new, I mean, the crown, is there any difference between your center line and the crown point? Is it possible? In our case it is not possible, but in some cases it is possible. Just think that if you are going to have some wider median, the center line may be at the center of the center median, the crown point is at the edge of the center median. Okay, now in this case there is no such offset, therefore it is 0. Then left sample. Now I'll just tell you a trick to find these things. Remember, in Civil 3D, wherever it says left, you have to remember it is negative, minus, right? Then sample, wherever you see the word sample, they are asking about our design lane. Okay, so left sample point offset. So what is your lane width that you are proposing? 3.5, right? So what is left sample point offset from the center line? Minus 3.5. How do you find it? Left minus sample, that is design, then minus 3.5. Then they are asking right sample point offset. Right. Now remember, wherever they are going to have right, it is plus. Then sample means the design. So how much is should this be value? This value be right, 3.5. Then trim. Now in this case, if you see the word trim, they are asking about the existing values. Okay, left trim means the existing road edge. So we don't know a value. So what we are going to do is, we are going to assume a value. Later we are going to attach it with an alignment. Okay, alignment in the sense, the existing LHS alignment, existing RHS alignment, we are going to attach them with the alignment. Now, here instead of drawing this typical sub-assembly, we are going to give a value, that is 2.5, right? 2.5, because usually our existing road should be within the design road. Okay, usually. So it is left, therefore minus. So we are assuming 2.5. Okay. Then right trim, therefore it should be plus 2.5. So left overlay slope options, that means how it should consider the left sloping options. So we are going to give it as outside lane super elevation. So you have to consider that corridor with the super elevation, outside lane super elevation. Default left overlay slope. If there is no super elevation, what should be the slope? What should be the slope? What is the crossfold in the Sri Lankan road? Huh? You don't know. Minus 2.5, right? Right overlay slope options, again we are going to give outside lane super elevation. Default right overlay slope, 2.5 minus or plus? Huh? Minus, not plus. Here, even though it is right, it is minus. Don't give plus, that it is super elevated like this. It is minus 2.5 both sides. Then slope tolerance means whether these slopes, whether any tolerance should be provided. Usually we give it as 0. No slope tolerance. That means we don't ask the software to decide on any tolerance. Everything it has to do according to our instructions. Then here use profile. Remember, this is very important. Use profile, always we have to give use minimum clearance. Okay. Now when we are going to create cross sections, we are going to give this use profile as use profile itself. Here, can you see? There are two options, use profile or use minimum clearance. We keep use minimum clearance as it is. Then finally they are asking minimum clearance and overlay depth. Okay, now do you remember what is minimum clearance and overlay depth? Here overlay depth is this overlay. Minimum clearance is what is in between the overlay and the existing road. Now, usually what we do is, now you know our overlay depth, we take it as varying cost, that is 40. and minimum clearance we give as 60. That depends on your pavement design, right? So you have to now if you had only overlay depth there, just think it is only 50 millimeter overlay depth. Now how you are going to give it? One thing you can do is you can give, remember these minimum clearance and overlay depth cannot be void, cannot be null, right? You have to give some value, otherwise it's not going to work. So one thing you can do is, if your overlay depth is just 50 and there's no any other layer in your pavement design, what you can do is you can give overlay depth as 49 millimeters and minimum clearance as 1 millimeter. Okay, never give null values here. Shall I show you the giving the null value what will happen? It is coming, maybe yeah, maybe they have corrected it here in year 2003 23. Earlier what happened was there was just one line coming. Okay. So we'll keep it as minimum clearance 40 and overlay depth, sorry, minimum clearance 60, overlay depth 40. Then you press apply and OK. Now you can see this is your design road on top, the part of the design road on top of the existing road. Okay, understand, this is part of the design road on top of the existing road. After that, here what you are going to get? The widening sections. Okay, widening sections. Then after that you are getting shoulders and then the drain or whatever, right? Right. Then save the drawing. Now we did this creating the recambering assembly. We created this one. Okay, and then we gave these things and then we created assembly. Okay, then we are going to creating the existing tie edges and design lane edges alignments. Okay, so for that, you have to find here where are your existing tie edges, these two yellow color lines. Okay, these are the two tie edges. Can you see that the layer is also tie edge? Okay, then we are going to make them alignments. It is very easy. One thing you can do is you can select these two, sorry, select these two and then right click, isolate objects, isolate selected objects. That is for your convenience, right? Isolating is not necessary, right? Then what we'll do is we can make this an alignment. We can make this an alignment. Now one advantage in Civil 3D is if you have a polyline, you can make it an alignment. You don't want to draw in it, you can convert it into an alignment. Now this is not the case in some of these Bentley software, because I remember now when I was doing Hatton Novelty Road, the consultant was using some software from Bentley. Now I was using Civil 3D. That was somewhere around say year 2011 or something. Okay, you were born. Right. Okay, so in year 2011 or something, then he was drawing the alignment using all these tools, and in my case what I did was I converted the alignment into, sorry, I converted the polyline into alignment. So that is very easy in Civil 3D. Okay, so we'll create the alignment. Now do it with me, alignments, create alignment from polyline this time. Earlier we did create alignment by layout, right? Create alignment from polyline. Select the first line arc polyline, or here this one. You can't select. Why? Huh? Some problem, we don't know what. Now this is a surface drawing. I didn't do anything intentionally, but the surface drawing, although it shows as a polyline, you can't select it. So this may be something, maybe because sometimes he has used some other software, some serving software to create this polyline. So it is not recognized as a polyline in Civil 3D. So in that case, what we can do is you can explode and you can make them polylines. Okay. So explode, type explode. So explode, enter, select objects. You select everything here like this and then press enter. Now check if it is exploded. Ah, yes, explode. Then before making them polylines, what do you have to do? Flatten it, right? Flatten. Now select everything like this and then press enter. Remove hidden lines. No is selected. Press enter. Now you have to give that sequence of instructions. What are these things? We did that in this class, isn't it? Yeah. So we'll go for PE, P edit, enter. Select polyline or multiple. It should be multiple. Press M, enter. Select objects. Select this one. Enter. Converts lines, arcs and splines to polylines. Yes or no. Yes is selected. Y. Enter. Enter an option. That is J. Join. Enter. Enter first distance. 0. Okay. Escape. Right. Now we'll see. Save the drawing. Now we'll make them alignments. Alignments. Create alignment from polyline. Okay. Alignments. Create alignment from polyline. Then select the first line. You can select this one. Now it is selected. See. Now when you are going to select, don't select the line in the middle. Okay, select in the beginning. Otherwise the alignment direction may be different. Okay. You select it and press enter. Now it shows the alignment direction. Can you see here? Do you agree with this? That's okay, right? Press enter. Now you give the name. Usually I give E, that is existing, LHS, ELHS. Then this type is offset, site is site 1. There would be no labels. You untick this add curves between tangents and untick this erase existing entities. If you want, you can keep it. Then what happens is you delete that, you erase that polyline, and you make it a polyline. So that depends on your requirement. Sometimes it's necessary, sometimes it's not necessary. Okay, but I'll keep it. Okay. Okay, shall we do it from the beginning again? If you have any questions, alignment, create alignment from polyline. Select the first line or this one. Press enter. Oh, there's one question. Existing TER deleted in previous class. Then how I import? Why did you delete it? Did you delete it? If you deleted it, you open the service drawing, then copy these two lines and then paste it here. Okay. Right. Alignments. Create alignment from polyline. Select this one. Enter. Then the direction is the one that is selected. We give ELHS. Site is site 1. There will be no labels. Untick add curves between tangents. Untick erase existing entities. Press OK. Now your alignment is being created. What are the single family? Can you do the policing making part? Polyline. My god, polyline, I think that we did so many times. Okay. Okay, I'll do it quickly again. You export everything. Now have a look. Huh? Now it is exported. Now what I do is I flatten it. Flatten everything. Then you go to the sequence of instructions. PE, enter, select polyline or multiple. It should be M, multiple. Select object, select everything, press enter. Convert lines, arcs and splines to polylines. Yes, Y is selected, enter. Enter an option J, join, enter. Pass distance is 0, enter. Now press escape. Now this will be a polyline. This will be also polyline. Okay, we'll quickly create two alignments, ELHS and ERHS. ELHS is the LHS existing tie edge. RHS is the ERHS is the existing RHS tie edge. Alignments, create alignment from polyline. So I'm going to select this line LHS, press enter. Here this is the direction that alignment is coming, press again enter. Give the name ELHS and this type is offset, site is site 1, alignment label set is no labels. You untick these two. And now I forgot to remove the alignment labels. So what you can do is, now don't worry if you forgot, what you can do is you can select this edit, you can select the alignment, go to edit alignment labels, import label set, no labels, apply, okay. Then what about the single family thing? Single family in the sense what they are telling is that there are the alignment is coming with this narrow curves and things, that is what they are telling. So what you can do is you can remove this. You can't just select and copy, right? You select this single family, you go to edit parcel styles and go to display, and here you see plan model section, everything you have to switch on. Shall I do it again? Select the single family, you go to edit parcel style and then you go to display. Here under plan, remove this one, so I mean switch off this one, model switch off this one, section switch off this one, apply, okay, it's gone. Now in the same way, we can create the other one also as ERHS. Alignments, create alignment from polyline. You select this one, enter. You select the direction, give the name ERHS, type is offset, site is site 1, alignment style is RD design style, alignment label set is no labels. You untick these two, press OK. So these are your two existing tie edge alignments. Save the drawing, and after that you go to right click, isolate objects, end object, isolation. Right, so after that we have to create the corridor. Okay, now once we have finished creating these two alignments, now what we have to do is we have to create the recambering corridor, right? So for that now you have to start using corridors, create corridor, corridors, create corridor. And then you have to fill this dialog box. Name usually I give RC, that is recambering corridor. Now corridor style, it's basic, keep it as it is. Baseline type should be alignment and profile, keep it as it is. And alignment should be DCL. Okay, and then the profile, that is EG surface. So that is the surface that we are having for the time being. And assemblies again RC, the one we created now. Target surface is again EG. Okay, then press OK. Now check whether the name is RC. Name can be anything. Corridor style should be basic. Baseline type should be alignment and profile. uh, and alignment should be DCL, the center line alignment. The profile should be the existing ground surface. Assembly should be the RC, or the one that we created. Target surface should be the existing ground, and then press OK. So you are getting another dialog box. Here you have to give all the details. Now you can see horizontal alignment is here. They have selected DCL. Okay, vertical baseline as existing ground. That's okay. Assembly is RC, the one we created. That's also okay. Then the start station of the alignment from the end station of the alignment. If you want, you can change them. Just think that you are having something like 25 kilometers or something. So you can't create all the corridor for 25 kilometers in one file. So if you want, you can take it from 0 to 5 or something like that. But here, since it is just 200, say 2.5 kilometers, is pretty okay. So we'll go to these frequencies. Will you select this one? Frequency, it is 25 throughout. Okay, so we are going to change it. Okay, how did I come here? So here under the frequency, you can select this one, this button. Now they are asking, see, the we see the corridor information. It's already there, we can't change. Horizontal baseline along tangent, what should be uh, the distance? It should be 10 meter, because only in 10 meter intervals they have taken the levels. Okay, so it should be 10 meter. And along curves at an increment, that means in 10 meter intervals. Okay, like in increments. Curve increment again 10. Here everything should be 10, right? Because we have taken levels only in 10 meter intervals. Along sorry, along spirals again 10. And at horizontal geometry points, don't give, because we have not taken levels specifically in horizontal geometry points. Okay, at super elevation critical points, we haven't taken levels specifically in super elevation critical points. Therefore there is no point creating the corridor there. Along vertical curves again 10 meter. At vertical geometry points, we haven't specifically taken levels, so no. At high low points, of course, we haven't specifically taken levels. So what I'm telling is, everywhere we have taken the levels only in 10 meter intervals. So there is no point asking to create a corridor in different points. Okay. At offset target geometry points, no. Adjacent to offset target start, no. What else? Along offset target curves, none. Right. Then you have to press OK. What is the baseline and region parameter that we kept ticked at corridor creation? That is, I think, the center line and the profile, that what you are asking, because that is the only center line and the profile that we are having, the CL and the EG. Okay, then press OK, and then you have to go to targets. Okay, then crown offset target, you can select this one. So you can select here DCL, but the problem is now you know this is different in your versions. I think if it is lesser than 2023. Okay, if it is 2018, it's different. They are having somewhere here to select. So what I will do is, I'm not sure whether I'm having Civil 3D 2018 with me. We'll see. Civil 3D. No, I don't have. So you will have to check it from this book, right? Here, so we did, creating corridor. We came here and we gave the frequencies as well, and then here target mapping. Can you see here ground offset target? Here only you can give. Now these DLHS and DRHs are not really necessary, right? If you want you can give, but they do not have any impact on our corridor. So I'll do it from the beginning. Corridors, create corridor, RC. Here basic alignment and profile. Alignment is DCL. Profile is EG surface. Assembly is RC. Target surface is EG. Okay, so I have to correct them again. 10 at an increment. 10 again 10. No, no, 10. No, no, then no, no. Okay, and then the targets. Of course, crown offset target, here you have to select it like this, DCL. But in earlier versions, it is being selected somewhere here. Okay, crown offset target, here you have to select, right? Then left sample, that is left. So LHS sample, that is design, DLHS. Okay, then left trim. Okay, left trim E. Why it is E, right? ELHS. Right sample DRHS. Right trim ERHS. Okay, any questions there? Now in this one also the same thing. Round offset target ECL. Left sample offset target DLHS. Left trim ELHS. Right sample offset DRHS. Right trim offset ERHS. Okay. This is also same thing, but the presentation is different here. Okay, now check round offset target DCL, left sample offset DLHS, left trim offset ELHS, right sample offset DRHS, right trim offset ERHS. Okay, if everything is given, you can press OK and then apply, rebuild the corridor, and then press OK. So you can see the corridor being created here. Yeah, rebuild the corridor. Okay, now this is the corridor that you are having. Now after that you go to corridor properties, select the corridor, select the corridor. So you go to corridor properties. So wait. Yeah. Now here in year 2023, of course there is corridor surfaces also. Otherwise, earlier what we did was, you select this corridor and then you can go to corridor properties and then come to surfaces, right? So here you can add create corridor surface, and then while this data type is links and specify code is top, you can add the top surface. Okay, understood. Then press apply and okay. Right now if you go to general tool space, you can see under the prospector, under surfaces, there are two surfaces. One is EG, other one is RC8. What does that mean? EG is the existing ground, RG8 is the one that we created now. That means we ran this typical cross section along the road, given the condition that what minimum 100 millimeter thickness should be maintained. After that, we created a surface, its top surface. So it is there now. Now we are going to add it here to the profile view. Okay, now we are going to add that into the profile view. To do that, you go to profiles, create profile from surface. Profiles, create profile from surface. Now, while this alignment is DCL here, you can see there are two surfaces, EG and RC8. But here, there is only one surface, EG. So what you can do is, you can select this RC8. RC8 is the recambering surface. Then press add. Now, instead of going for draw in profile view, you can press OK here. Right? Now, this is that recambering surface. Can you see RC8? This one. So there should be 100 millimeter throughout. Now, if you don't feel very comfortable with this same color, what you can do is you can select this profile. Okay, RC8 profile. Go right click, go to profile properties, and you can change this object style into XNG ground road copy and apply and OK. Now you can see your recambering profile is shown in magenta color. Any questions? Yeah, here you can select this one, go to profile properties, and then object style should be XNG ground road copy. Just to change the color, right? Nothing else. Then apply and OK. Now you can see this is your recambering profile. Yes, any questions so far from the Zoom class? Yes, from the physical class. Any questions? Okay. Sorry. If you have finished this, now we are going to design the vertical profile. Okay, we are going to design the vertical profile. Now for that, you have to go to profiles, create profile by layout. Earlier, we went to create profile from surface. We tried create profile from surface. Now, we are going to go to create profile by layout. Okay, profiles, create profile by layout. Select it. Then it says select profile view to create profile. You select this profile view. Once you select the profile view, you have to take it by the grid. Not in say this one, no, this one, these profiles or whatever. So you have to get it from the grid. Then there comes create profile, draw view, alignment DCL. What is the name of this new profile? Usually we give FG, finish ground. Okay. And profile style is RD finish. Profile label style is finish profile design parameters 2. Okay. Then press OK. Once you press OK, you are getting a profile layout toolbox like this. It is just like that our alignment design toolbox. Using this toolbox, you can create the profile. Now, before going to the design of what design of profile, you should know the theory behind it. Okay. Where is that book? This one. Here, if you go to vertical alignment, crest vertical curves, that is 88. Vertical curves. You know there are some parameters. Now, as an example, now what is our design speed here? It's 50, right? So it is 50. Here, stopping side distance should be, now that means the K value for crest curve minimum should be 9.8. Okay, and for the 50 minimum curve length should be 50, and for sag curve, as far as I remember that I haven't included that table here. So for 60 kmph, what is the sag K value? 12, 12. So just keep that in mind, right? 12. So in the next revision, I'll just include it. I think I have forgotten to include it somewhere here. This book. Okay. So shall we start now? To start designing the vertical profile, what you are going to do is you have to start using draw tangents. Okay, draw tangents. Start point, we are going to select this point. or snap on and off depending on the way you want it, right? Now, what is our minimum curve length? I told you 50. So if it is 50, where are you going to put the IP point? At least it should be here, right? 25. If you are going to put it somewhere like 10, can you have a 50-meter curve? No, right? So you have to consider. So I'll just keep it like this. Now this is first one. It is just a rough guideline. Okay. Later we can change. This is just how we are going to put that roughly, right? So I'll put it like this: 25. Then it should be 25 into 50, right? So 25 plus 50, that should be 75. So something like this. And then 75, 50, 125. Okay, so because if you are going to do it, it is easy like this. Otherwise, later you will have to change these points. And then 125. After that, another 50. How much? 175. Then 225. You have to match with the recambrian profile, right? Then 275. Can you see that you can't do it like this? Okay, it's not matching. There comes a heavy fill. So maybe we'll have to change it. Anyway, we'll keep it like this. Then of course you can't go by 50-50. Okay, because the shape is different. So maybe we'll go like this. Now as I told you last day, so here in this space your eyesight should be excellent. Okay. Now this is just a rough guideline. Okay, later we are going to change it. Now suddenly if it goes like this, then what you're going to do? Again you have to start from the say draw tangents and select where you stopped with or snap. Okay. Then no harm. Okay. So you come here. So only thing is here you have to train your eye for this. Okay. There is no such calculation. What now? What has happened here? This should be wrong, right? Can you understand this one? So we'll see what has happened there. It is 100, say 100. Sorry, 1600 or something like. Okay, we'll see what has happened there. Yeah. Look here, this is again the levels are wrong. Finally press enter, right? Now you have to think, now yeah, you have to complete this, right? So yeah, we'll wait some time until it is been completed. Okay, now we have created the first one, that means the preliminary profile to match as much as possible with the recambering profile. Okay, now there are two other steps that we have to do. One thing is we are going to insert curves and match it with the recambering profile. Remember that you are going to match it with the recambering profile, okay, not with the existing profile. After that we have to fine tune it using the checking the differences between the recambering and our finished ground profile. Okay, that's second step. The third step is we have to check the k values. Yeah, k values, because the profile lengths, of course, we are providing when we are inserting the curve. Shall we start? So the first thing here, look, this is 0, so we have put that into the recambering profile to the exact point the recambering profile starts. Then here, right, so we have to get, I told it's 25, but of course I can't exactly put that in 25, so later I can change that into 25. How? Here, can you see this green color one? Maybe in year 2018, 19, something like it is different, right? Okay, so whatever, anyway, you have to get is profile grid view. Profile grid view, that is different, that is right to the profile layout parameters. Okay, because what I'm telling is earlier versions, it is the symbol is different. Take this profile grid view. It is third from right. No, sorry. You have to get profile layout parameters, right? Sometimes it may not come, then you will have to double click it. Now it's coming. After that, you have to select, see, select PVI. It is 1, 2, 3, 4, 5, 6, 7, 8 from right. 8th from right, okay. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 8th from right. Select PVI. So how you are going to get this? You have to get this profile layout parameters, 4th from right, and then 5, 6, 7, 8. 8th from right, select PVI. So it says pick point near PVI to select. Here 26, so it's there, PVI station 26. I'm going to make it to 25, and I take the cursor here and right click. It's 25. Then what about this gradient? It's pretty okay, right? It's not lesser than 0.3%, it is not greater than 6%, then it's okay, right? Then I'm coming to here, it is 75, but anyway, if you want to make sure, because this may be there is some difference, because it shows only up to 3 decimals, okay, so we'll make it exactly into the 75. Here, can you see it's 75, 35, 75, right? Now I am going to insert a curve here. So you have to select the curve tool bit, 1, 2, 3, sorry, 3, 4, 5, 6, 6 from left. Here you have to go to more free vertical curves and free vertical parabola, PVI based. That is only of the first instance that you have to do. Then you can just click it. Okay, free vertical parabola, PVI based. Now in the first, don't jump to free asymmetric parabola and select that. Okay, that is also okay, but usually in Sri Lanka we don't use free vertical parabola PVI based. Okay, then it says pick point near PVI or curve to add curve. So I'm going to select here. It says specify curve length or pass through K. Pass through K. So I will give the curve length 50 and enter, and then press escape. Now you see there came a curve. Okay, and it shows begin vertical curve station, begin vertical curve elevation. Here end vertical curve station, end vertical curve elevation. Then you have to change here also 126. So I'll make it 125. Why I am making it 125? Otherwise there will be broken back curves, there will be small segments in between curves. Okay, so I'll make it 125. Then I'll put a 50-meter curve here. Now you can just select here. You need not to go to more free vertical curves, parabola base, because it is already selected here, right? You can just click here and come to this PVI point and select and give the curve length 50. Now can you see, now we have decided the vertical profile up to here, but can you see here? There is a difference between this, our design profile, and the recambering profile. We have to check whether this is permissible or not. Now, please understand that you cannot always expect tree camberin profile to fall exactly on your design profile, or your design profile to exactly fall on the tree camberin profile. If it is like that, then of course you don't want to do a design. Okay, there may be differences, but we have to minimize the difference. That is our task. Okay, why? If you are going to, this is pretty okay, but only thing is now you are providing more asphalt than necessary, than required for the road strength requirements. But that should be minimum. Okay, that should be minimum to maintain the design standard. Okay, sir. Now don't go to curves like this. That is also okay. That's also okay. Then the strength wise is also okay, and maybe design geometrical design wise okay. But what about the cost? Cost is high, so we are going to that should be a balance. Okay, the strength should be maintained, design, the geometric design standard should be maintained, and the same time cost should be minimized. That is all what we are going to do as a design engineer. Okay, then here look, here of course the problem is recambering profile is here, and our design is going down. Is this permissible? No. Then of course we will have to trace this IP or this IP. We will see in the next step. Now first what we are trying to do is we are going to match our design profile as much as possible with the recambering profile. Okay. Right. Then we'll change this 175 also. 175. Then we'll provide a curve here 50. Right. And then this 175, this should be 225. So I'll give a curve of 50 here. Right. Then of course can't you change this? This is 225. and you are going to have a very big field here. What can you do? If you want to provide 50 kmph, of course I don't see any other method that you can do. Okay, of course if you are going to go for say 40 or something, then what you can do is say using this move PVI 1 2 3 4 fourth from the left, you could move this PVI here. Look, you select the PVI and then put at the place you want. Okay, but now the problem is you cannot have 250 curves here. Understand the problem? You cannot have 250 curves here. Then if you are going to reduce the curve length, you cannot maintain 50 km. Okay, so there is no any other method that you can do. So it is 275. So maybe there has to be a or one another thing what you can do is, okay, that I'm just telling you methods, right? You remove this IP. Okay, here delete PVI. You remove that IP. Okay, and then what you can do is you take this here and see, so we'll put it like 220. Always try to put that into integers, right? And this should be minimum 250, right? So if it is 260 also, that's okay. 260. Then we'll see what we can do. Okay, we'll give a 50 curve here, and this should be 270, right? 270. Then maybe I can take this IP. But anyway, you can't take it out, then there will be cutting here. Okay, then you can put 50 here. Now what happened? There is no heavy filling anywhere, but there is filling here and there is filling here also. Now what is the difference here? 10, 20, 30, 40, 45. So you can't put 45 because you can take this down as this. Can you see here? Like this. But then there is no enough space here. But if you are going to take it 5 meters here, what happens? Then there is a filling here. So it seems like there is no method to reduce the fill. Okay, in that case you have to wonder what I am supposed to do. Whether I am supposed to maintain the 50 because this is a rehabilitation project, right? Now we will go down and see what is our existing, sorry, our design what? Design horizontal line. It is 78 meters radius. What is the speed that you can go? Yes, tell me. It is 50? No, it is not 50. Why? For 50 you have to go to minimum 100 meters. If it is 78, what is the design speed you can have? Check your tables. I think it's 40. I think 40 is 40 or 30. No, 40. Right? If your horizontal alignment is going at 40, if your horizontal alignment is going at 40, is there any necessity to make this 50? Just think about it. Horizontal alignment is catering only for 40 kmph. Okay. Then your vertical alignment, you are going to provide it for 50 kmph with the high field. Is that required? No. So you can reduce this into vertical also, you can reduce into 40. Now for 40 kmph, what is your, then again we'll have to see that table. Because you can't by heart the tables, right? Here vertical alignment, say we put like 90. For 40 k is 4.7, and for 40 the curve length is again 40. Okay, so you can go for 40 here. So we'll try to do that way. Okay, so what we'll do is we'll make not 50, we'll make it 40. Then I think you can put 50 here. We'll try. It's not taking. Why? Mm, First we'll remove this curve. Then put 50 here. There's a problem, right? This should be 175 exactly. 175. Okay, then we'll put 40 here. So here you see this one also can be 40 because it is 78 curve, right? This can also be 40. Okay, so we'll go to 40 here also, and here we'll insert a curve 40, right? And now what we can do is we can move this here. Look, so what I can do is I can take this into 260 exactly. Now how is this? No filling at all. Okay, no filling at all. How did we manage to do this? Because we considered it as this region as 40 kmph. This was possible because the horizontal curve was going for 40 kmph, not for 50. Okay, because now in such a case, if you provided 50 kmph design speed for the vertical curve with heavy filling, it is not going to be worth. Right, then the next thing. This box, if this box disappeared, you select this profile and then right click, go to edit profile geometry, so it will be coming. Right, now here of course you can match it as much as possible with the the recambering profile, like this. See, like this. Right, so we'll try to take this into 330. 330, and then again you need not to provide say it is for 40 kmph is going, but since we have it like this, we'll try to provide 50 or 60, we see, depending on this profile, the recampaign profile. So we will give 50. 50 is matching. Okay, now time to time you have to save the drawing, right? And then you have to consider this one. So we'll take this into say 400, and this is 400. Then this should be 450, right? Otherwise you can't have straight line. So 50 is okay. So we'll take this into say 450, and then you have to take this into 600, sorry, 500. Right, now we'll see whether we can match 50 here. 50 here, also 50, and here also 50. Now it's pretty okay, right? And then here you can see this will be matching if you are going to take it into here. Okay, later we'll trace these things. Okay, so we'll take this into say 555 and give 50 curve. Seems okay. Now the problem is here is going to be 0.07. Okay, so you can't do that. So for that you will have to insert a curve here, somewhere here, not curve, some IP here, and you will have to, you select this IP, and you see grayed out is 0.28, you make it 0.3 minimum. Now this is not enough, 0.27. So first you have to set this one, say this is 670. So we'll go for 670, and we'll take this grade in point 3 minus 0.3. Okay, now 624, 670. No, we have to take this into 620. Why? There should be minimum 50 in between. Okay, 620. Again you will have to increase this into minus 0.3. Okay, then you insert a curve here, 50, and 1, 10, 20, 30, 40. So you will have to take this IP again into say 720, and then you can have 50 here and another 50 here. Now you will have to bring this IP here, otherwise you can't give 50 curve. 770, and 10, 20, 30, 40. So you will have to go to here, 50. But the problem is, even if you give 50 here, it will not come like this. We'll see here. So it is not satisfying the recamber requirement. Okay. So there can be some any other method. Okay, some other method. You will have to check. We'll see what we can do. So maybe you will have to go forward and backward to come up with the proper profile. So maybe no, it's not going to be like this. So we'll remove this one as well. We'll put it somewhere here, and we'll remove this one as well, and then we'll try to have only one IP here like this. Okay, it's just a trial and error method, right? Anyway, you will have to maintain 50 meter in between. It is 747, 709. So we'll take it to 100, sorry, 800. Okay, then this should be 750. So can you match it here like this? $750. So now you can have 150 here and 150 here. And in that case, of course, you will have to press this one and maybe this one also to match with this recambering line. We'll see. These things we'll have to change later. So here what I see is I can remove this IP, right, and take this IP somewhere here. Here of course there comes a fill, you can't avoid it. Okay, can you see? 1 10 20 30 40 50. Either there is some problem with levels or whatever, I don't know, because the road cannot come like this. Okay, so what about here? It is 850, and then maybe you can go 50 here. It's pretty okay. So you can remove this IP as well. Okay, there is no much change. So we'll take this into 120, yes. So maybe we can have some IP here, and say, yeah, 940. Then maybe we can have some big curve here, say 100. Okay, then some 60 curve here, because the 50 is the minimum one, right? Then again this is 190, sorry, 1090, and that should be 140. Thousand 140. So we'll have 50 here. Here of course you can remove this IP. Very small difference. Can you see? So you can have IP here. Not the IP curve here 50. And here we'll make it 100 and say 1280. And here we'll make this into 340. Oh, what happened? 1340. Okay, then we'll have 50 curve here, another 50 here. Now you can see that the recambering is above the design profile. Okay, so we'll have to change this later. And here maybe we'll take this into 1430, and here sorry, 1480. Right, so we can have 50 meter here and another 50 meter here. And we'll take this into, so we can move this one here, right? Look. Okay, so we'll make it 1545, and you can take this into somewhere here 1595. Okay, so I have 150 curve here, another 50 curve here. This one of course we'll have to change with the cross sections. Okay, this is wrong. And then we'll take this as 1680, and maybe here 1650, and this one here, sorry, yeah. Now we'll try here maybe some 70. Okay, 70 matches, another 70 here. Okay, they are matching. Then this should be, now you have to bring it here 810. So you can't keep this 0.13, right? So if we set this into say zero point 0.3, what will happen? It's like this. So we'll make 8,883, and then we'll give this say 50, and here how we are going to set this. Yeah, it's 957. Then this should be 2070. Now we'll have 50 here, and shoot, you can't do that way. Maybe you will have to remove this one and think some method. Okay, so you can see here, because this is very high field, so we'll take this IP somewhere here, and say this IP somewhere here, right? Then we'll have another IP in between. Okay, 960 2010, that is okay, but the problem is say 1960, and this one say 2010. Now that is okay, but only thing is there will be say some racing here. Okay, racing of course we'll do later. 50 here, another 50 here, right? Then maybe we can remove this IP and take this IP this way. You have to match with the pre-computing profile here. So it seems okay. Then we'll have something like say 100-meter curve. Pretty okay. And here of course you have to create set something like this. We'll keep here how much, 200, yeah, 2135. Okay, and here maybe 200, 2247, 2247, and then we'll have this should be minimum zero point 0.3, right? And then we'll have 50 here. Okay, so can't we remove this IP? Oh, then what happens? 25 here, 1 2 3 4 somewhere here. We'll see. No, you have to change this IP somewhere here. Yeah, then what we are supposed to do, 2297, okay, and then 50 here, then this should be 2347, 50 here, and this one, the final one, maybe 2405. Okay, and maybe 70 here or 50 here, right? So that is the end of our second stage of what? Designing the vertical profile. Save the drawing time to time, right? And after that, what you have to do is you have to select this profile view, and you see, can you see that vertical geometry is not the finished vertical geometry is showing, and you can see finished road level and existing ground level are both same, so they need to be corrected, right? So for that, you select this profile view, go to profile view properties, and then go to bands. Okay, so what you're going to do, you are going to select this profile view, go to profile view properties, and then go to bands, and here station you have to change as FG, profile 2 also as FG, and then you have, sorry, sorry, no, not this one, it's the same thing. What you have to change is finish road level, EG should be FG, this one should be FG, and then vertical geometry you have to select FG, these two and this one, and then press apply. Okay, any questions here? Finish road level, you have to change the profile 1 and 2 as FG, and then that's the second one, and then 1 2 3 4, fourth one, vertical geometry, you have to change this into FG and apply and press OK, and you can see here they have been changed. The vertical geometry is the finished one, and the finished ground levels are also different from the existing ground level. Now in the meantime, you have to check your K values. Okay, if the K values are adequate. Now at the first glance, what I can see is K values are pretty adequate, so you don't want to worry about them. Of course you have to check with the table, right? Here 12 is enough as I remember. Okay, now yeah, so that is the end of today's lesson. Now next day we'll discuss how to say like how to fine tune this vertical profile. Okay, fine tune in the sense, now you will see this is not the optimum profile that you are having. Okay, so we have to optimize it. So any other questions that you are having? And next week we'll be discussing